All right, hi there. So today we are doing Unit 4, Lesson 1. So this is part of a self-study unit to help us stay stay up to date on where we're supposed to be at in our curriculum. So this is the first of a series of 3 videos for Unit 4. So Unit 4 isn't long. As a matter of fact, if we were to do this in class, it would be less than a week. So I'll do the 3 lessons here with you guys, all right? And then afterwards, when we come back, I'm gonna do an activity with the class and then also give you a Common Core O state exam questions, all right, as practice, homework, and bonus. And that would give me a pretty good idea of how much information you guys have absorbed in this unit, all right? And I just checked the audio. The audio sounds fine. And so hopefully there's not too much commotion, all right, outside my classroom, even though this is after school already on a random Wednesday. So now, Unit 4 talks about signed numbers, which means positive and negative numbers, but not in a way where you have to add, subtract, multiply, divide, meaning you don't have to operate on them. You just need to understand some basic definitions and concepts. So this is why I feel very confident about letting you do this at home. So understand that when you do this, all right, you don't have to do any worksheets, all right? Just take notes, because that's one way for me to tell whether or not you actually watch the videos. And this is also a way for me to make sure that you guys actually paid attention, okay? All right, now, so Unit 4, Lesson 1. So by the end of this unit, I'm really hoping that you guys understand how, where do signed numbers stand, all right, in the family of numbers, and then knowing some of the definitions. And then if I were to show you some situations, would you be able to, how do I say it, decipher some of the words, okay? All right, into numbers. Okay, so let's jump into it. Okay, all right, so this is the family of numbers. So if you want, you can copy it down in the way that this is presented, all right? If not, you can just list them out. So let's start with natural numbers. Now, some of these might get, how do I say, it might get very lecture-like, might get a little bit philosophical, but that's okay, all right? Because my goal here is to try to mimic as close to an actual lesson as possible. And I really hope that, you know, you don't just know the definitions, but also know the meaning behind these definitions and really understand where do these numbers and the categories come from. Okay, so the first one is, okay, if you were to think about numbers, right, as they were first invented, probably thousands of years ago, right, when the human being, you know, we were hunting and we're looking at, we see animals, right? If you see one animal, right, you can conceptualize that there is one. So in some ways, even animals can count. For example, the animals can count in groups of 3s and 4s. Okay, so they don't say 1, 2, 3, 4. So they can look at a group of animals and split them by easily manageable groups. So like 3 and 4, so they kind of know that there's 7, right? So likewise, if we see one, I don't know, zebra in the wild, and then we see another one, zebra in the wild, naturally, we can make the conclusion that there are now 2 zebras in the wild, right? So that's the birth of arithmetic, all right? Arithmetic just means operation with numbers, okay? So that's a study, that's a branch of study of mathematics. So here, when we're talking about natural numbers, we're talking about numbers like 1, 2, so on and so forth. Those are natural numbers, meaning numbers you can count, actually. So for example, you can't count 0, right? And you can't actually count negative numbers. So that's a natural number. Now, what's a whole number? So a whole number, it's a series of numbers where you don't have any decimals or percent or fractions. So 0 is a whole number, right? So is 1, so is 2, so on and so forth. That's why, as you also see, these circles become larger and larger because they're just a family. So in other words, in a set of all whole numbers, natural numbers is one of them with the exception of 0. So 0 is a whole number, but 0 is not a natural number because you can't find 0 in nature. Like it doesn't, like there's no number that stands out like that. Okay, so moving on into a larger and larger family, now we have integers. So what are integers? Well, integers are whole numbers, but now they include 0. So all the whole numbers. All right. But they also include positive and negative numbers. So now you got -1 and -2. Okay, so that's what integers are. Next, rational numbers. Rational numbers, you can remember rational numbers by looking at this word ratio. What's a ratio? Yep, it's a fraction. So any number that you can put in as a fraction, like 2/3, or as a decimal, like -2.7. All right, or another fraction like 1 1/4, right? These are rational numbers because they can be put in as a fraction. So for example, if I were to ask you, hey, can you write 0.5 as a fraction, what would you say? Right, you say 1/2, right? 5/10, which is 1/2, right? As you can recall from the decimals unit. So that's how you do that, okay? Now, so what are irrational numbers then? Having said that, irrational numbers are numbers that you cannot put in as a ratio. So no ratio. Now, that's strange, right? Because you all your life you're in math class, and you learn that you could put things as ratios, as fractions, as decimals, percent. So you would assume that everything can be put into a ratio. So for example, right, even 100, it's a rational number. Why? Because you can put in 100 as a fraction, right? It'll just be 100 over 1. Whereas irrational numbers are numbers like this, pi, right? Because pi is actually a non-terminating decimal. So the question is like, how are you going to write a fraction where the answer, so to speak, if you were to convert from a fraction to a decimal, where the number is a non-terminating, non-repeating decimal? All right, now another rational number is square root of 2. All right, now you will explore that further in high school, so I won't get too deep into that, okay? And then now you're talking about real numbers. So what are real numbers? Okay, well, this is the whole family of real numbers. So that begs the question, right? What is there such a thing as an unreal number? All right, maybe I should type this, but all right, too late. Is there such a thing as an unreal number? Yes, there is actually. All right, and we call those imaginary numbers. All right, so this is deep into high school territory. So if you're not quite understanding what I'm saying here, it's okay. All right, this is a little bit beyond your age group here. So what's an imaginary number? It's a number. So for example, all right, now I'm going even deeper. So for example, if I were to ask you, right, what's the square root of 4? Which means something like this. What number multiplied by itself will give you 4? So what times what? Using the same number will give you 4. What would you say? Yep, 2. Right? So for example, let me ask you another question. What's the square root of 25? In other words, what number times itself will give you 25? What would you say to that? Yep, that's right, it's 5. So that's what a square root is. So where am I going with this? Well, imagine, right? You have a square root of 1. What's the square root of 1? In other words, what number times itself will give you 1? Yeah, 1, right? 1 times 1 gives you 1. But the problem is then, what number times itself will give you negative 1? And the answer is, well, there isn't any, right? Because 1 times 1 is 1, and negative 1 times negative 1 is also 1. So again, now we're going into 7th grade territory. So what they do is they would use the letter I to denote that this is an imaginary number. It doesn't exist for the sake of math, okay? So, all right, I just had a couple of visitors. Where was I? So yeah, imaginary numbers don't exist, but like I mentioned in class on several occasions already, sometimes mathematicians perform mathematical operations, maneuvers, let's just call it that way. All right, for math's sake, it's like solving a puzzle for the puzzle's sake. Now, I'm sure there's some genius out there that can rebuke what I said, because I'm sure there's probably some practical application to the imaginary numbers, but perhaps I don't have the intellectual capacity or the time to actually go over that. So, all right. Having said all that, so those are the definitions. So let me erase this real quick. All right, so let's move on then. All right, let's talk definitions. All right, something a little bit more digestible for all of us is this. So let's see. All right, more definitions. All right, you're gonna have to write this down. So in exchange for not having any worksheets or homework to do, per se, this is what you have to do. Okay, so an integer. What's an integer? It's a member of the set of positive whole numbers, right? All positive numbers, 1 to infinity. Negative whole numbers, right? Negative 1 to negative infinity, and 0. That's it. Okay, what's a negative integer? Any number that's less than 0. All right, okay, now we're about to get philosophical for like a couple of minutes. 0. So one of the things that I learned that I thought was fascinating about 0 is that we didn't even conceptualize 0 up until probably, oh my God, what was it? Let me see. I actually printed some like notes for these lessons. So let me just double check. When was it? Yep, 3,000 years ago. Now you gotta understand, we've been around for 35,000 years. Okay, so using 0. Let me just double check. Yeah, using 0 as far back as 3,000 years ago. It's pretty amazing, actually. So the story of 0, it's I mean, listen, some of you again might think that 3,000 years ago is a long time, but knowing how long we've been around, that's just a drop in the ocean. So now, so where did that come from? Well, I mean, think about this, right? It's really hard for us human beings to conceptualize 0 and then like actually put a symbol, right, to represent 0. So because think about this, if your friend were to ask you for money, you're not gonna say, well, I have $0. You don't say that. You say, well, I have no money. Right? So again, like so it's very, very hard to conceptualize 0 as a number until, what I would say quite recently. Okay, now moving on to the next thing. So here we have a number line, right? We spoke about this early on in the year with fractions. When we were comparing fractions, we started with 0 in the middle. As you go to the right, the numbers get larger and larger. These are positive numbers. As you go to the left of the 0, get smaller and smaller. These are called negative numbers. All right. Let's see. Moving on. Next one, we got opposite numbers. So what are opposite numbers? So the opposite number, it's a number on the other side of 0 that matches that same number. So for example, okay, so for example, now looking at this one, right? If you're looking at this number here, which is 4, what's the opposite of 4? Well, it's the corresponding number, the number that matches 4 on the other side of 0. So since this is a positive number, if you go to the other side and count 1, 2, 3, 4, the opposite of 4 is negative 4. Now, similarly, what's the opposite of negative 3? Think about that. That's right, positive 3. Okay. Here's the question though, all right? What's the opposite of 0? That's right, 0. 0 does not have an opposite number. 0 is already at the beginning, right? Okay, now, next concept. Absolute value. So people get opposite numbers and absolute value confused all the time. All right, by the way, feel free to pause if it helps you taking notes, and rewind if you don't entirely understand what I'm saying. Okay, it's okay. Now, absolute value is a little different from opposite. So absolute value basically is asking you, how far is this number? So what's the distance of this number from 0? So for example, all right, now this is already given as example, so I'm going to use a different number. So let's say 5, right? And by the way, we write absolute value with the number and then 2 really long bars like this, okay? So what's the absolute? So in other words, how far is positive 5 away from 0? It's 5. However, if I were to ask you, how far is negative 5 away from 0? In other words, what's the absolute value of negative 5? What would that be? Yeah, still 5. Okay, because they're not asking you where on the number line it is. They're simply saying, I don't care from either the positive side or the negative side. I just want to know how far that number is away from the central number, 0. Okay, now let's move on then. So whereas, let me add this, whereas an opposite number, the opposite of a positive number is a negative number, right? And the opposite of a negative number is a positive number. The absolute value of any number, it's always a positive number. Okay? You're not going to get a negative number as a absolute value. That's just not going to work. Okay? All right. Now let's see. Moving on. Okay, let's practice then. All right, based on what we learned. Let's see if we could finish this in 3 minutes. All right, let's make this happen. Okay. Okay, you can just read that. Negative numbers are integers. What? From 0. Yep, less than 0. All right. Positive integers are integers what? Than 0. Greater than or more than 0. Okay. All right. What's neither positive or negative? And we call it the origin. Yep. The next part, you have to you have to order these numbers, or you'd have to number the number line, which is not difficult. All right, I know. So let's see, 0, 1, 2, 3, 4, 5, and then 0 to the left, negative 1, negative 2, negative 3, negative 4, and negative 5. Now, if by the way, if this lesson for any reason, was a little too difficult to comprehend, you can feel free to find me here in the morning, okay? I can go through this with you again. All right, write the letter value represented by the pointer for each letter. Okay, so let's point K. Now, K, what's K? That's 0, right? What's the opposite of 0? I just mentioned this. Yep, 0. All right, 0 doesn't really have an opposite number. And then what's the H? What's the opposite of negative 5? Yep, positive 5. What's the opposite of M, which is 4? What's the opposite of 4? Right, negative 4. And then lastly, what's the opposite of negative 2, which is represented by point P, which is what? Right, that's right, 2. Okay, so yeah, that's that. All right, we got this under 20 minutes, so that's not bad. And despite I just keep going on and on. So, all right, okay, thanks for watching. All right, bye-bye.